Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss on the calorific value of the fuels. So what are the types of the calorific value and what is the calorific value? We are going to see in detail today. So we are going to focus mainly on the calorific value and the definition. What is calorific value and what are the types of this calorific value and Dulong's formula, which is going to use to calculate the calorific value of the different fuels and what is the importance of this calorific value. So what is calorific value? So the calorific value is a total quantity of heat liberated when a unit mass or a volume of fuel is burnt completely. So this is the total quantity of heat liberated. So when a unit mass of volume was burnt, the total heat liberated is called the calorific value. So the calorific value is the primary property of a fuel and its capacity to supply heat. So the fuels essentially consist of, generally the fuels are hydrocarbons. If you take wood or these are like organic substances like petroleum byproducts are all contains hydrogens, carbon and oxygen and some hydrocarbons, and the heat that particular fuel can give is due to the oxidation of carbon and hydrogen. So the heat producing from this fuel is due to the oxidation. The process of the oxidation of carbon and hydrogen gives the heat in the fuel. Further, the heat produced is different because depends upon the fuel, the heat produced will be the different and it varies and is termed as its calorific value. So this is different for different fuels. Even the calorific value is different for different fuels. The calorific value of a fuel may be defined as the total quantity of heat liberated when a unit mass or a volume of the fuel is burnt completely. Burnt completely is nothing but the process of combustion. This calorific value, also known as the heating value or the energy content. So the measure of the energy released during the combustion of a substance. It quantifies the amount of heat energy produced per unit of the substance. So the total quantity of heat liberated when a unit mass of fuel is completely burnt in the presence of air or oxygen. So this is the process of this burning or the combustion process should be carried out in the presence of air or oxygen. This is called the calorific value of a specific fuel. So what are the calorific value of fuels? So this is the heating value of a solid or a liquid fuel. It is defined as the amount of heat liberated when it completely burnt in the presence of air or oxygen or by complete combustion of 1 kg of fuel. So 1 kilogram of fuel, the heat generated by, we are mentioning a unit volume. Here the volume is 1 kg of fuel. So the calorific value is typically expressed in terms of joules per kg, or it also can be expressed in terms of British thermal units, which is called BTU, or per pound. So or for per LB, BTU per LB, which is called British thermal units, and also expressed in kilocalorie per kg of fuel at NTP, and SI system is the joule per kg. Generally, it is expressed in terms of joule per kg or mg per kg. There are two types of calorific value. One is GCV and LCV. So GCV is nothing but the gross calorific value, also called as the higher calorific value, which is called HCV, and LCV, which is called lower calorific value, LCV, or net calorific value, NCV. Means the higher calorific value is also called as the gross and lower is also called as the net. So HCV or gross, here LCV or net. So the formula which we are using to calculate This calorific value is Dulong's formula. This is an mathematical expression used to estimate the higher calorific value or gross calorific value or the lower calorific value called as net calorific value of a fuel based on its composition. Means it based on the composition means carbon, hydrogen and sulfur composition. This Dulong formula will be calculated. By this formula, we can find out higher calorific value as well as the lower calorific value of the fuels. So the formula relates the calorific values to the percentage of carbon means carbon, so the composition. Here we are referring to the composition of the specific fuels, which is the percentage of carbon, hydrogen, sulfur as well as oxygen present in the fuel. So coming to the higher calorific value, which is called the HCV or gross calorific value. So it is a total heat is liberated by complete burning of 1 kg of fuel of including heat of steam. So which includes the heat of steam formed by combustion of hydrogen in the fuel. So this is the total heat liberated of 1 kg fuel, which includes the steam formed during the combustion process of hydrogen. The HCV represents the maximum amount of heat released during the complete combustion of a specific fuel. So HCV is calculated by the formula using this is here carbon and hydrogen and oxygen and sulfur, which is expressed in terms of kilojoule per kg. So see here 33,800 carbon plus 1,44,000 again hydrogen minus oxygen by 8 plus 9270, which is the sulfur plus kilojoule, which is expressed in terms of kilojoule per kg, where C is the percentage of carbon present in the fuel and H is the percentage of hydrogen present in the fuel and O is the percentage of oxygen present in the fuel and S is the percentage of fuel present in the sulfur. So the HCV of a specific fuel can be calculated according to the composition means hydrogen, oxygen, sulfur and carbon present in the fuel. By taking this into consideration, we can calculate the HCV means higher calorific value of a fuel. So the coming to the lower calorific value, which is also called as net calorific value, it is a total heat is liberated by completely burning of 1 kg of fuel deducting heat of steam formed. Means HCV means it is a maximum amount of heat. We are including the steam. Here we are excluding the steam in the steam produced or steam formed in the process of combustion of hydrogen in the fuel. So we are including means we are adding the fuel this steam here in HCV. So here LCV means we are excluding. So deducting the heat liberated due to the steam by the combustion of hydrogen is called the LCV. So the LCV accounts for the heat lost due to vaporization of water formed during the combustion process. It can be estimated from the HCV using the relationship. So by knowing the HCV means higher calorific value of a fuel, we can calculate the lower calorific value of a fuel by using the relationship formula, which is called lower calorific value is equal to higher calorific value minus 9H2 is the hydrogen and 9H2 into 2466, which is expressed in terms of kilojoules per kg. So the calorific value of the heat contained in fuels or fuel, which is determined by using an apparatus called bomb calorimeter. So the complete combustion of a specific quantities means which may be the quantity of the fuel at a specific temperature and a pressure at a constant pressure and in normal conditions can be determined by using the bomb calorimeter. This is the bomb calorimeter which is used to calculate or to determine the calorific value of a fuel or a food. So Here, this is the thermometer which is maintained at a temperature surrounded by a water. Here, the food or the fuel or food is taken in a crucible. Here, this is a sample is taken in a crucible and at a constant pressure. We are maintaining the pressure at a constant rate under oxygen. So here in the first itself, we known that we have read that it should be carried, the combustion process should be carried out in the presence of oxygen or air. So this process also has to be carried out in the presence of oxygen. So this is the air jacket and the water jacket. Here this is full of water. Here this is the agitator. This is to get the uniform for homogeneous temperature and pressure. And this is the thermometer. This is the crucible containing sample. And under test means we are going to test this sample. So the electrically heated wire to ignite the sample. So these two wires are introduced into these are the two wires. They are introduced into the fuel or the food sample. They are electrically ignited, and this combustion takes place in the presence of air or oxygen under constant pressure. So this gives, so the heat liberated was calculated, and the heat liberated was determined by using this bomb calorimeter. So when it was ignited, it start burning. So the complete combustion under constant pressure and temperature, the heat liberated was noted down, and we can know the value of the calorific value of the fuel or a food by using this apparatus. So as we know, these fuels are the calorific values differs from fuel to fuel because it mainly depends on the composition. So depends on the composition of the fuel. Composition is nothing but the percentage of carbon, hydrogen, oxygen and sulfur in the fuels. So there is a list of fuels and its calorific value. So coming to the wood, it is having 17,000 to 22,000 kilojoules per. This is kilojoules per kg. kg. So this is kilojoule per kg. So coming to the coal, which is also having high calorific value of 25,000 to 33,000, and the petrol will show 45,000. So mostly petrol, kerosene and diesel, they have the calorific value of 45,000. Next, methane and compressed natural gas, which is showing 50,000 calorific value, followed by liquid petroleum gas, biogas and hydrogen, which is 55,000. Biogas is 35,000 to 40,000 and hydrogen is 1,50,000. So this is the calorific value of different fuels, which varies depends on, because the calorific value was determined by using the composition of the fuel. So as the composition differs, the calorific value of the fuel definitely differs. So the amount of heat generated by different of fuels varies depending on the nature of the element and the proportion of the elements present in them. So the calorific value varied because of their nature of the elements present in them, and the proportion means the varied proportion present in the fuels definitely results in the varied levels of calorific value. Coming to the importance of the calorific value, why it is important, why should we determine this calorific value of different fuels? So when fuels are burnt, it has the capability of generating electricity in the thermal power generating plants. So the best fuel to produce electricity largely depends on its calorific value. To know at what temperature this capability of generation of electricity happens, to know that we have to know the calorific value of a fuel. So the greater the calorific value, the greater is the efficiency of the fuel and better is the fuel. So the performance is better means ultimately the greater calorific value means the performance will be better. Keeping awareness of the calorific value of fuels, which helps in ranking the fuels. We can rank according to their calorific value, because so which burns effectively, which gives high heat. So some industries we need very high heat, high temperatures are needed. If we know which fuel is effectively burning and which fuel is effectively giving heat. Based on this calorific value, we can rank these fuels. Fuels with high calorific value are considered to be a good fuels because high calorific value means the production of heat is high, as we are burning this fuel because of the heat production. So if the calorific value is high, then it is considered as a good fuel. So the calorific value increased, then it is called as a good fuel because it increase in efficiency. So this is the best fuel because of improved performance. So this is the increase in calorific value is considered with the higher calorific value is considered as a good fuel. So what are the applications of this by the determination of this calorific value? Higher calorific values or gross calorific values of fuels is an important parameter in various applications where the total energy, which includes the steam production of the heat produced by the steam under the this combustion of hydrogen, the energy released during combustion, including the latent heat of vaporization of water, is a critical factor. So, some applications where the HCV is particularly irrelevant means they are more accurate energy content measurement. So by finding out the HCV, we can know the more accurate energy content measurement, then optimized energy efficiency. Then in power generation thermal plants, the improved power generation efficiency can be done by the calculation of this HCV. And enhanced cogeneration and combined heat and power. So these are called CHP system. So this is the combined cogeneration and combined heat and power system, and increased a district heating efficiency, which is effective from steam generation, called optimized waste to energy generation or conversion. Then improved boiler and this furnace performance in the industrial level, and enhanced thermal application in the transportation, and accurate assessment of biomass energy, and also efficient utilization in industrial cleans and dryers, the R&D of the energy system. By using this HCV means higher calorific value, we can know the accurate and the enhanced or the effective or increased or optimized or improved this power generation system, as well as the systems in industries, even in the cleans and the dryers, as well as here this for boilers and furnace. So in industrial level, even in the R&D level, due to this, due to the determination of this HCV, this gives the improved and efficient systems, and due to this, these are the applications due to the determination of HCV in the fuels. These are the applications in the very different levels of industries, as well as in R&D systems, as well as in power plants. This is all about the HCV, which is called higher calorific value, and LCV, lower calorific value. This is all about these types of this calorific value. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.